For assignment number 2, we are officially starting our unit on right triangles called trigonometry. And in this unit, we're going to be finding missing sides and missing angles of right triangles. One of the most basic theorems for right triangles is called the Pythagorean theorem, and it is used to find a missing side of a right triangle. So if you look at the equation here on the left-hand side, we have a squared plus b squared equals c squared. If you watch the video, it showed a visual proof of that equation. So where's a squared? So if you look at the right triangle, first of all, how do we know it's a right triangle? Because it has a 90-degree angle. You'll notice that they labeled two of the sides called legs and the other side called the hypotenuse. The hypotenuse is always opposite the 90-degree angle, so if you draw an arrow directly across the 90-degree angle, that would be the longest side called the hypotenuse. So in this equation, you could choose either leg as denoted A or B. It doesn't matter which one you choose, because in the equation, you're just going to be adding those numbers together anyway after you square them. So this equation is saying if you take this side length A and you square it, and you add that to, switch the color here, this side length B and square it, that total, if you add them together, should get you the hypotenuse side length C squared. So if you look at this visual proof, it shows a numerical proof of the Pythagorean theorem by actually filling in what A squared and B squared are, and that total should equal C squared. So if I look at side length A, if I count the units across, or the boxes across, there's 3 boxes there. So if I take that and I square it, that would be 9 units total, right? So 9 plus, here we have side length B, which is 4 units across, and if you square that, 4 times 4b, 16. So if I add this together, I should get C squared. In other words, 9 plus 16 is 25. So in this picture, I should get 25. So if I count the boxes across, there's 5 boxes here. So if you square 5, you get 25. So this is a visual proof to show the Pythagorean theorem. So all we're going to do for the next examples is apply this theorem. You're going to be given 2 sides of a right triangle. You're just going to plug it into this equation to find the third missing side. And you can use the Pythagorean theorem as long as you're given 2 side lengths. However, you could also use it if you're given isosceles right triangle, because 2 of the side lengths would be the same. So let me switch the screen here to the next part down on the notes. Here we go. All right, so apply the theorem. So I'm going to write the theorem at the very top right-hand corner here. So a squared plus b squared equals c squared. And again, the most important part is, can you identify c, the hypotenuse? That always has to be on the right-hand side of the equation. So if I look at number 1, first thing I'm going to do is I'm going to locate the hypotenuse. I'm actually going to highlight that. So let me grab my highlighter. So the hypotenuse always has to be opposite the 90-degree angle, so this would be the hypotenuse. So in this case, we are finding the hypotenuse. So you could give it a variable. You can call it x. You can call it c if you want to use the Pythagorean theorem. I'm just going to call it x. So since I'm given 2 sides of a right triangle and I'm finding the missing side, I can use the Pythagorean theorem that says a squared plus b squared equals c squared. So the 3 and the 4 would be the legs. It doesn't matter which one you choose to be A or B, because if you look at the Pythagorean theorem, you're going to be adding them together, so it doesn't matter the order in which you add them. So I'm going to say A is 3 and then B is 4. And I know that the hypotenuse, the longest side, which I highlighted there, is my C. So if I plug this into Pythagorean theorem, I would have 3 squared plus 4 squared, and that's equal to c squared. So I just need to square these numbers. So 3 squared is 9, 4 squared is 16, and that's equal to c squared. So 9 and 16 give me 25, and that's equal to c squared. And lastly, the opposite is squaring a number. Since we have to get c alone, the opposite is squaring is square rooting. So if I take the square root of the right side, I have to take the square root of the left side. So c is equal to 5. And in fact, This example here was just proven in the previous visual on the notes above, where you had a 3, 4, 5 right triangle. So the missing side here is 5 units. All right, for number 2, I'm going to locate the hypotenuse. It has to be opposite the 90-degree angle, so this would be my hypotenuse right here. So therefore, we are given the hypotenuse and we're trying to find one of the legs. Since we're trying to find one of the legs, it has to be less than 13 because the hypotenuse is always the longest side. So I'm going to label my numbers here. So I'm going to call A 5. The missing unknown here, X, that's my B. And then the hypotenuse here is my C. So my equation is a squared plus b squared equals c squared. I chose 5 as being side length A, so 5 squared plus our other leg here, our unknown. You could call it X, you could call it B. So this is my unknown, so I'm plugging in X and squaring it, or you could just leave it as b squared. And that's equal to 13 squared. So if I continue to solve, 5 squared is 25, plus x squared is equal to 13 squared is 169. So to get x alone, I need to subtract 25 from both sides. So I'm left with x squared is equal to 144. And then lastly, I take the square root of both sides to isolate the x. So the square root of 144 is 12. So that missing side length there is 12. And I know my answer makes sense because my value has to be less than 13 because the legs always have to be smaller than the hypotenuse. All right, so you notice that in number 1, our side lengths were 3, 4, and then the hypotenuse was 5. And then in number 2, our side lengths were 5, 12, and 13, with the hypotenuse being 13. If you get 3 whole numbers, those are called Pythagorean triples. So some common Pythagorean triples, 3, 4, 5, we just showed, 5, 12, 13, and then these are some others to kind of memorize. That way, if you're given a right triangle and you have these memorized, you don't even have to show the work. You already know that, hey, if I see 3 and 4, I know the hypotenuse has to be a 5. Or if I see a 5 and 13, I know the missing side here is 12, if you have those memorized. The numbers underneath here that you see growing larger, those are just a scaled version of the original. For instance, if you look at this first picture here, there's that 3, 4, 5 right triangle. If you're dilating this by a scale factor of 6, dilate means grow larger. In other words, you're multiplying all 3 sides by 6, you create a new Pythagorean triple. This is definitely not drawn to scale, but I'm going to draw a larger right triangle. So the new side lengths would be 3 times 6 would be 18, 4 times 6 would be 24, and then 5 times 6 would be 30. So it would belong in this list here. You would see 18, 24, and 30 in that list. In this next example, you have your 5, 12, 13, and you're dilating by a factor of 4. So you're multiplying all 3 originals by 4. And when you do that, you create another Pythagorean triple. So 5 times 4 is 20. 12 times 4 is 48. 13 times 4 is 52. So this Pythagorean triple would belong in this column here with the 5, 12, 13. So those are just some to memorize if you wanted to go ahead and memorize some Pythagorean triples to make it easier for you. All right, let me erase this and we're moving on to the back side. For the back side, all we're doing is applying the theorem. So again, a squared plus b squared equals c squared is our equation used to find a missing side of a right triangle. So for number 3, we are given a right triangle, and we are first asked to fill this blank in. So it says, will my answer be larger or smaller than 27 is what we're trying to fill that in with. So the first thing I'm going to locate is the hypotenuse. 27 will be the hypotenuse because it's opposite the 90 degrees, so I know 27 has to be the largest side. Therefore, what I'm trying to find, which is x, should be less than 27 because it's a leg, not the hypotenuse of the right triangle. So my equation here, a squared plus b squared equals c squared, is what we're using to find the missing variable. So let's identify a, b, and c. So I know definitely c is 27 because we just highlighted that as the hypotenuse. And then the x and the 16 are both legs, so it doesn't matter which one you choose as your a or b, because you're just going to square those numbers and add them together, and it doesn't matter the order in which you add them. So let's plug this in. So a squared, so I'm plugging in x and squaring it, plus b squared, so 16 squared, and that's equal to c squared, so 27 squared. So now we just need to solve for x. So I would have x squared plus 16 squared would be 256, and that's equal to 27 squared. If you type that in, you should get 729. To isolate the x, we're going to subtract 256 from both sides. And when we do that, we would get x squared is equal to 473. And then the last step, in order to isolate the x, the opposite of squaring something is square rooting. So we're going to take the square of both sides. When you type this into a calculator, we're going to round to the nearest tenth, one digit after the decimal. So if I type in 473 and hit square root, it's approximately 21.7 units. So that makes sense because, again, our answer should have been less than 27. All right, for number 4, first thing I'm going to do is locate the hypotenuse. I know that x is the hypotenuse because it's opposite the 90-degree angle. So that should be the longest side, and therefore I could fill in my sentence. Now, will my answer for x be bigger or less than 27? It's going to be larger because it's the hypotenuse. It should be the biggest side. So my equation, a squared plus b squared equals c squared. Let's identify a, b, and c. So again, we already said that x is your hypotenuse, so there's your c. And then the other legs, it doesn't matter which you choose as your a or your b. So I'm going to make a 22 and then b 27. So plugging in, so a squared, 22 squared, plus b squared, 27 squared, and that's equal to c squared or x squared. If you type in 22 squared in a calculator, you would get 484. If you type in 27 squared, you would get 729, and that's equal to x squared. If you add these together, you get 1,213 is equal to x squared. And then lastly, take the square of both sides. So when you type this into a calculator, 1,213 hit square root, you should get approximately 34.8 rounded to the nearest tenth. And again, that makes sense because it's larger than 27. For number 5, we are given a picture with 2 smaller triangles and then 1 larger triangle if you trace the large triangle of the entire picture. So if you look at the 2 smaller triangles here that I have on this the right-hand picture, you'll notice that these 2 triangles are exactly the same by hypotenuse leg, and the reason they're the same is they share the same hypotenuse because there's tick marks. So if this left-hand side is 24 with a tick mark and this right-hand side has a tick mark, then I know this is 24 units. So I could add 24 there to the picture, and those are the hypotenuse of the right triangle, and then they also share the same leg length, x. So by hypotenuse leg, these are identical. So if all the way across is 22, you just cut that in half, and those would be 11s. So if I just take one of these, I'm just going to draw this one over here. So I have 11x and then 24. So again, my equation in order to find a missing side is a squared plus b squared equals c squared. Let's identify a, b, and c. Where's my hypotenuse? 24 has to be the hypotenuse because it's opposite the 90. So therefore, c is 24. And then it doesn't matter which one you choose to be your a or your b. So I'm going to make x my a and then 11 my b. So let's plug this in. A squared, so x squared, plus b squared, 11 squared, and that's equal to c squared or 24 squared. So I would have x squared plus 11 squared is 121, and that's equal to, if you take 24 and squared in a calculator, you should get 576. So So to isolate the x, subtract 121 from both sides. So from here, you should get x squared is equal to 255. And the final step is to take the square root of both sides, round to the nearest tenth. So if you type in 455 and hit square root, you should get approximately 21.3. That makes sense because it's less than 24. It can never be larger than the hypotenuse. Lastly, for number 6, we're going to have to draw our own picture. So it says, if the diagonal of a square is 11.3 meters long, what's the perimeter? So first thing I'm going to do is draw a square. And then I'm going to draw a diagonal. A diagonal goes from corner to corner. So there's my diagonal. And that diagonal tells me is 11.3 meters long. We are asked to find the perimeter. The perimeter would be adding all 4 sides of this square. I know that a square has all sides exactly the same length, so if this is x, then this would also be x. And technically I could put the other 2 x's here. I need to figure out what x is and add that 4 times, right? Or multiply by 4. However, I am just going to include 2 of these because I'm going to focus on the right triangle right here. Every square has 90-degree angles. So my right triangle here, I can use the Pythagorean theorem, a squared plus b squared equals c squared, even though I have, it looks like 2 unknowns that are identical because they're both the same variable. This is an isosceles right triangle, therefore I can use Pythagorean theorem still. So this would be my hypotenuse because it's opposite the 90. So I'm going to label my A, B, and C. So this is my A, this is my B, and this would be my C. So if I plug this into Pythagorean theorem, I would have x squared plus x squared equals 11.3 squared. So think of combining like terms. 1x squared plus 1x squared is 2x squared, right? Whenever you combine like terms, all you're doing is adding the coefficients in front or combining them together, and the variable in exponent stays the same. And if you type in 11.3 and square it, you should get 127.69. So from here, how do I get x alone? Well, I need to divide both sides by 2. So I would have x squared is equal to, if you divide 127.69 by 2, you should get 63.845. We're going to round in the very last step. So lastly, the opposite of squaring something is square rooting. Take the square root of both sides. Now I'm going to round to the nearest tenth, and you get approximately 8. So x is equal to 8. So all 4 sides of the square would be 8 units. So if I have to find perimeter, you're just adding all 4 of these together. 8 plus 8 plus 8 plus 8, or in other words, 4 times 8, which is 32. So my final answer, the perimeter, would be 32 meters, since the units were meters. So 32 meters.